Alright, let's start with classification. Let's start with this dataset, which can be solved using a linear equation. And we're going to keep the learning rate to 0.03. We're going to change the activation to sigmoid. And we're going to start with the basics. So we're going to remove the hidden layer. Let's remove the hidden layer. You can do this. And then you can also remove all the neurons except one. So this becomes a perceptron in that case. Alright. Now let's go ahead and run this and see how many iterations it takes for it to classify this training data. Alright, let's go ahead and start it. So as you can see, the numbers are reducing and this is pretty good. So 0.03 is very good. That becomes 99.997. That's pretty good. And you can see the weights here are pretty heavy actually. 3.2, 1.4, 1.2. You want to see the epochs here. So it took 144 iterations. So we started with the learning rate of 0.03 and the activation function to be sigmoid. You can change this to linear, and let's run this now again and see how long it takes. So in this, you see the test loss is a 0. This took less than 50 iterations to achieve a test loss of 0. What we understand is that each case is different, and each case you have to use a proper activation function to get the best result. Alright, we're going to go back to sigmoid just because it takes a bit longer, so that's easier to understand the impact of the learning rate. Now if I increase the learning rate to 0.1, you will see that it will take much less iterations. So let's go and try this now. So you see that in less than 50 it has achieved 0.03. Took about 144 I think in the first time we tried with sigmoid and a learning rate of 0.03. So what we understand is that by increasing the learning rate for a certain type of a problem, in this case which can be linearly solved, the learning rate plays a significant role in reducing the number of iterations in the training stage. Now we're going to take a slightly difficult problem. So we're going to freeze the learning rate at 0.1 and let's choose a different data set. So let's go to a circular data set here. This cannot be solved using a linear equation. So let's see how this performs. So first we're going to try with sigmoid and a learning rate of 0.1 and see what happens. So let's go and run this. So as you can see that the test loss is reducing and the training loss is also reducing. The test loss is kind of hovering around 500. Training loss is actually reducing. So you see that this is somewhat of an example of overfitting, is that the test loss is not decreasing proportionally to the training loss. In some cases it is increasing. So it's not working out really nicely. So let's go and pause this. So with this we understand that it has taken 637 iterations and it has got to a test loss of 0.508, which is not good.